Alright, welcome back to this third video of the 5-part series for you to learn how to use Revit on the University of Toronto Seismic Design Team. And in today's video, or I guess in this third video, we'll be looking at how to properly define and draw beams. So, as you can tell, we're looking again at the same Revit that I had in the previous video with our 4 columns already defined, looking absolutely beautiful. And in this video, we're going to look at how to make beams. Therefore, we will start on the level 1 plan view, since that is the start of our first floor plan. So, just as general knowledge, whenever the DNA team, or Design and Analysis, DNA team, makes a floor plan for our proposal, it'll generally look like a 2D view, as you can see here. So you'll have, say in this example, we have 3 floor plans, one different one for every third of the tower. So it's our job to model this in a way that we are sure that it can be built and everything will fit properly. But this is a little bit complicated for now, so we'll only be designing this little smaller floor plan, a lot more simple. Granted, these dimensions are 4 inches by 3 inches. We will be working on 12 by 12, but it'll generally be the same shape. So this kind of diamond thing with a line going through the middle, with obviously our perimeter beams going all the way around, hugging the columns as I was referring to in the last video. So let's head back to Revit and let's start doing that right now. So just in the same way that the columns would snap onto the middle of our lines, the beams are the same way. So let's make the design lines for our beams and offset them the same way that we did for our columns, but at a different distance so we can use our beams to do so. So our beams, at least in this example, are 1/8 of an inch thick. Therefore, the center of them will be at 1/16. So we can go back to this offset tool that we know and love, input in 1/16, click enter, and make that offset for both. And there are the middle of our beams that we can already define right now. So again, structure, column was the last video. Now we're looking at beams. So let's start our beam here and end our beam there. And that should be our beam defined. Sometimes the snap-on is a little bit strange in Revit. As you can tell, I clicked here, but my beam auto-snapped there. But that's okay. Let's draw the other beam, and we can fix that afterwards. Starting from down here. Click. Click. Very easy. As you can see, the snap-on is a little bit strange, but that's okay. Just to extend our beams, you just have to click on it. There's these 2 arrows here. Just drag it. There you go. And then our beam is at the correct size. I can do the same thing with this beam here. Delete our design lines since they are kind of in the way. And we can do the same thing here. Drag it all the way down. Just as another little bit of context, whenever we're making our perimeter beams, the current philosophy in how we make the perimeter beams is that any given beam will only extend into one corner. So you can tell this beam here, this top beam, it extends into the corner here. Therefore, I will not extend it all the way down. I'll only bring it to the column such that the other beam will go there. All right, so now with these 2 first beams already defined, I can go back to our trusty method of using our mirror tool to define the rest of the beams. So again, a design line down the middle. It doesn't matter which kind of 2 points you decide to make that diagonal line, as long as they're the same. I just picked the edges of those 2 columns because they were easiest to click and easiest to find. So again, click your beam. You know you clicked your beam when it is entirely underlined. Mirror tool, line, bing, bang, boom, done. Same thing on this side. Mirror tool, click, done. So nice and easy. And again, we can go back to making sure that Revit understands, hey, I want some of these beams going into the corners and some not. So it's just a matter of telling Revit, hey, this is how I want stuff to be. So this will stay there. And there you go. So now we can go look at our 3D view and see exactly how those look. As you can tell, I don't want to save the project. Everything, all of our 4 perimeter beams are hugging our columns. Therefore, we know we've done this correctly. But as you can tell, since I'm hovering it right now, our mass timber columns are 316 by 316, but our beams are 18 by 316. So let's go check out that property in our beams, and I'll explain to you a little bit how that works. So view, user interface, let's pull back up the properties, and as you can tell, just as I wanted, these beams are 18 by 316. But what if I wanted something different? What if I didn't want my beams to be that way? Well, I can just click here on the little drop-down menu, and I'll see that with the template that was provided to me, or I guess to you guys as well, there are 5 sections of wood that have been pre-selected. The first dimension is the dimension as you see it on the plan view, and then the second one is the one that you don't see. So if I wanted to change it, say to 316 by 316, I would just click it, and as you can tell, this beam got thicker. It stays centered on the design line that we had before, but that's not what we want currently. So I'll bring it back to 18 by 316, and that's how it usually goes. Provided with a template, you have 5 sections, and if you do want to make another one, just click any beam that you have, click Edit Type, duplicate, and then you'll be able to make another section. Obviously, the dimensions down here correspond to the ones that I named them here. So 18 is B, 316 is D, and it's the same thing as always. So whenever you're done that, just click Apply or whatever, and you should be fine. It's really not that hard to figure out with all the information that I've provided up to now. So that makes our 4 perimeter beams. So now we're going to start looking at the interior beams and what I call horizontal bracing. So that's kind of diagonal beam pieces that you would see in the floor plan. And we'll see how to make those. So just as a little refresher, this is what we'll be making. And to make our lives easy, we will start with this center beam since it is by far the easiest to make. I only have to extend this design line here. So if I left click onto this thing, I can drag it up. Let's drag it up properly. Here we go. And let's drag it down so that it can make our beam that runs down the middle. There are a lot of shortcuts to draw like beams and columns as such. So you'll have seen for design lines, I click DL. For beams or columns, I usually click up here, but as you can tell, column is CL and beam is BM. So let's try using BM right now. Start our beam over here and end our beam at the bottom. And it should be nice and beautiful. There it is. And just to double check, we can go back to our 3D view and see our nice beam. Amazing. So now to make kind of the diamond shape, there's something that you have to know about defining beams in Revit before we start. So every beam that I've drawn to now kind of have this squarish edge. So all I have to do is draw a beam in Revit and the default will be this square edge. I don't have to worry about it. But if I'm making these non-square edges, these kind of angled cuts, then I have to make what's called a reference plane that I'll be able to trim off the excess after and have kind of these angled cuts. So let's go to Revit. If you want to draw a reference plane, you can click this button right here, reference plane, or click RP and draw them just the same. So I'll click RP, start my reference plane at the corner, kind of where my beams have to be, or along the lines where I know my beams will be cut. So that's one reference plane. Left click here, left click down there. That's a second reference plane, a third reference plane to be made here, and a fourth. If you are wondering why I'm drawing them this way, don't worry about it. It all makes sense. You will see. So to make our beam, again, I will go BM, and I'll be able to click right here at this intersection. Again, if you look on the top right, I have the correct section of beam. If I didn't, you could just change it. Click here, and then come all the way down here at this intersection to draw the end of my beam. But as you can tell, Revit is being a little bit mean to me. The snap-on tool seems to think that I want a 45-degree angle as opposed to this intersection. So to cycle through all the different snap-ons, you can just hit the tab button until it finds intersection. Granted, I don't actually have a design line there, so it won't see it as an intersection. The beams do not count as intersections, just something neat for you to know. So let's go back to BM, click that intersection, come all the way here, cycle with tab, and there it is. Honestly, I probably should have waited for the pink rectangle just to make stuff more accurate. So let's actually do that. I'll make an intersection point with both design lines. I don't know why it's not doing reference plane to design line, but hey, let's do it now. Pink square, so I know I'm right. And then down to this pink square here. Cycle with tab. There you go. So now I'm center to center. All right, amazing. Then we can delete all these useless lines. Get out of here. Actually, I want to keep that one. Control Z. And let's leave this one. Actually, I'll need that one. Okay. So looking at this brace right here, what you'll see is that as for all the other beams, is defining it as the center, right? So the center of my beam goes through that line that I marked. But that is not the case for my design. So how do I change that? What properties do I have to change to make sure that actually it's this top side line of my beam, which is going to intersect here, just as you can see in the plan view, right? How do I make that happen? Well, if you click on this beam, or this floor brace, as I like to call it, you'll see that there's a section below constraints that we were using for the columns called geometric position. And that's kind of the constraints that you have to modify such that you can kind of have the correct definition of your beam. So to start, we'll look at the YZ justifications, and we'll make them independent so that I can control each side of my beam independent of the other. So let's start down here. And the Z justifications, we do not have to change those because that is already defined as the top of our beam being at the level of our choice. That I don't have to care about. What I do have to care about is the Y justification. So as you can tell right now, it is given by kind of the center of our beam, or the origin, however you want to call it. But we want it to be otherwise. So if I click left and I click apply, it should change. Granted, I probably changed the one up here. Yep, there you go. I changed the one up here. Left happened to be wrong. So I'm going to go right, apply, and there you go. The kind of upper side of my beam intersects exactly where I want, and that's okay for now. Amazing. We'll cut it later. And then go down here, and we'll do the same thing. So my start Y justification was up there, so therefore my end Y justifications will be down here. Let's click left. Left was wrong again. Therefore I'll click right. There you go. So now my justifications are all done correctly, just as I would want them to be. But now I have to do the trimming, as I mentioned earlier, which is why I made the reference planes. So to make that trimming, let's click on the beam and click the cut geometry button. So I click my beam, click on my reference plane, and it cuts my geometry just like that so that everything is nice and smooth. I'll show you on the 3D view after, but it'll look exactly like how I saw it on my AutoCAD model. So let's go do exactly that. On the 3D, we'll see. Nice cut, exactly how we would have it in real life. It looks beautiful. So now we can go back to doing our tested, tried, and true method of using the mirror tool to mirror everything around. So back to level 1, click the beam, mirror on the line. Amazing. Whoa. As you can tell, our cuts didn't transfer. but everything else did very well. So whenever you use the mirroring tool, when you want to mirror beams, it's just a matter of cutting it again. It really does not take that long. Click, 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 you're done. Amazing. And now we can do that same mirror again. I'll get rid of this line because it's, I don't know, it doesn't look good. Click on one, hold down Control, click on the other. Use that mirroring tool on our center line. And there we have our two other braces. Again, we'll go through cutting everything just to make sure it works properly, or it looks proper. Here we go, here we go, and here we go. So that should be the entirety of our floor plan, defined exactly how I wanted it to be done. And just to double check, we'll look at the 3D view again. And would you look at that? It is absolutely beautiful. Every piece of wood is 1/8 by 3/16, as it should, and our entire floor plan is done. So to conclude, in this video, we learned about reference planes, we learned about beams, we learned about the different sections, how to change them, how to create new ones. We did more mirroring and figured out a little bit more about our mirroring tool as it pertains to the cut, which is absolutely amazing for this third video. So in the next video, we will learn a little bit more about braces, how to draw those, how to use those. So for that, we're going to need grid lines again. But otherwise, thank you again for joining me.